Hello everyone. Imagine you are responsible for defending a military base. Suddenly, your radar detects one enemy aircraft. No problem. Modern air defense systems are designed for exactly that. But then something changes. Not one aircraft, not 10, but 300 small drones appear from every direction at the same time. Now, here's the surprising part: none of them is particularly powerful, none of them is especially fast, yet, together, they may become one of the most difficult threats modern militaries have ever faced. Because in the age of artificial intelligence, quantity can be can become quality. Welcome back to AbroDecoded. Today, we are going to explore one of the biggest transformation in modern warfare: drone swarms. Take a look at this flock of birds. Have you ever wondered how thousands of the birds turn almost instantly without crashing into each other? Who is giving the orders? Who is the leader? The answer is no one. Each bird only pays attention to the bird closest to it. It follows a few simple rules: stay close, don't collide, move in the same direction. That's it. And yet, together, they create something that looks incredibly intelligent. Scientists call this swarm intelligence, where complex behavior emerges from many simple individuals following local rules rather than receiving commands from a central controller. Nature has been using this principle for millions of years. Birds, ants, fish, bees. Now, engineers are teaching machines to do the exactly same thing. Let's compare two different ways of controlling a group. The first is centralized. Imagine every drone waits for instruction from one commander. Sounds organized until that commander disappears. What happens then? Everything stops. Now imagine something different. Every drone communicates only with nearby drones. There is no single brain, no headquarters, no central computer. If one drone is lost, the others immediately reorganize. The mission continues. This decentralized approach makes the swarm far more resilient because there is no single point whose failure disables the entire group. It's similar to how the internet keeps routing data even when individual connections fail. But here is the real question: if nobody is giving orders, how do hundreds of drones avoid crashing into each other? This is where AI becomes essential. Instead of telling every drone exactly what to do, the AI helps each drone make decisions using the information from its own sensors and nearby teammates. Imagine driving through busy traffic. You don't wait for someone in a control tower to tell you every turn. You watch the cars around you, you avoid obstacles, you adjust your speed. Drone swarms work in a similar way. The AI continuously helps them avoid obstacles, maintain formation, assign tasks, and choose efficient paths. And if one drone suddenly disappears, the swarm can quickly reorganize without waiting for human instructions. So now let's think like a defender. Suppose your radar detects 300 incoming drones, but your air defense system has only 20 interceptors missiles ready to launch. What happens? Even if every missile successfully destroys one drone, there are still 280 drones remaining. This illustrates a challenge often called the saturation problem. The defense isn't necessarily defeated because the drones are individually superior. It is challenged because there are simply more targets than it can engage at once. Instead of trying to build an unstoppable machine, modern military thinking increasingly asks a different question. What if many inexpensive systems work together? Sometimes the greatest weapon isn't the strongest one, it's the one that arrives in jaw dropping massive numbers. So now consider the economics. Imagine firing a very expensive interceptor missile to destroy a relatively inexpensive drone. If this happens once, it's manageable. But if it happens hundreds of times, the costs increase dramatically. Drone swarms shift the economic balance. Many drones are built from commercially available components and can be produced in large numbers. Interceptor systems, by contrast, often require sophisticated engineering and are much more expensive to manufacture. This changing cost equation is forcing militaries around the world to rethink how they defend critical infrastructure. So, does that mean drone swarms are unstoppable? Not at all. But there probably isn't a single solution. Instead, many defense planners are exploring layered defenses. Some systems use high energy lasers against nearby drones. Others rely on electronic warfare to disrupt radio communications or satellite navigation. And increasingly, defender drones are being developed to intercept attacking drones. In other words, one swarm may eventually have to fight another. The future of defense may not be about replacing one technology with another. It may be about combining many technologies into a coordinated system. And this is only the beginning. Researchers are exploring heterogeneous swarms where aerial drones, ground robots, and autonomous naval systems cooperate as one team. At the same time, advances in Edge AI allow more decisions to be made directly on each platform instead of relying on distant command centers. These developments could make autonomous systems faster and more resilient. However, one important point must be kept in mind here. The idea of fully autonomous combat without meaningful human oversight remains an active area of research and policy debate, not an established global norm. Technology is advancing rapidly while legal, ethical, and military doctrine continue to evolve. So, today, we learned that drone swarms aren't simply about having more drones. They are about completely different way of thinking. Instead of relying on one powerful machine, they rely on many smaller systems cooperating through AI. Sometimes the biggest technological revolution isn't making one machine smarter, it's making thousands of simple machines work together. But this raises even bigger questions. If machines can coordinate, make decisions, and adapt together, where should humans remain in the decision making process? That question will shape the future of warfare and perhaps the future of AI itself. So, if you found this episode useful, let me know in the comments. Do you think the future belongs to the larger, more powerful weapons or to intelligent swarms of smaller, cheaper systems? I'd love to hear your perspective. If you enjoy deep dive into AI, technology, geopolitics, and future of warfare, consider subscribing to Abro Decoded. Thank you for watching, and I'll see you in the next episode. Thank you.